client. And also we need the same configuration for the neighbor quad 3, the second neighbor quad 3. You know that for configuring the route reflector, we should only configure the route reflector. Clients don't know anything about the route reflection. Remote ACE is 65001 again. Update source is Loopback 0, address family IP for unicast, and route reflector client. Let me to copy this configuration in the switch 5. This is the configuration of switch 5, and checking the result. Okay, we have one error here, route reflector client, because we have one syntax error, route reflector client, and this is the route reflector client. Okay, very good. Again, copying the configuration and pasting here. Everything now is good. Also, we need one interesting and important things. Look at here, because switch 2 and switch 3 are edge switch, we need next hop self. In the switch 2, I should configure for the neighbor quad 5 next hop self. Okay, let me change it, next hop self. In the switch 2, first, we should go to the neighbor quad 5, address family IPv4 unicast, and then next hop self. That's it. And also in the switch 3, we need the next hop self. Here for the neighbor quad 5, next hop self. Okay, let me configure in the switch 3 for the neighbor quad 5, then address family IPv4 unicast, next hop self. That's it. Let's configure, check the BGP neighborship in the switch 5. Show BGP IPv4 unicast summary. As you can see, we have two neighborship with the switch 2 and switch 3. From switch 2 also we can check the neighborship, show BGP IPv4 unicast. Yes, we have neighborship with the only unicast summary. Okay, look at here, unicast summary, and we have two neighborship between router switch 2 and switch 1, and also switch 2 and switch 5. It's okay. Finally, in switch 3 we can check the neighborship, show BGP IPv4 unicast summary. Yes, we have one neighborship with the router quad 5 and one idle state neighborship with the router 4, because I didn't configure the router 4. Okay, and you know that quad 1 advertise from NXOS 1 to NXOS 2, and from the NXOS 2 advertise to NXOS 5. First, check the NXOS 5 BGP table, show BGP IPv4 unicast. Yes, we receive quad 1/32. Because this is a route reflector, it should advertise the route to the switch 3. Let me check the BGP table of switch 3, show BGP IPv4 unicast, and as you can see, we have quad 1/32. Okay, finally, we should configure the switch 4 for BGP. I can start the configuration with the copying the configuration of the switch 1. This is the configuration of switch 1, and then I can paste the configuration for the switch 4 after some change. Switch 4 conf t host name is switch 4, and we need the configuration of BGP. Let me copy the configuration of BGP from here, copy and pasting for the switch 4. Okay, switch 4. Then feature BGP first should be enabled. Router BGP 65002. The router ID is quad 4. Address family IPv4 unicast should be enabled, and also net for quad 4/32 should be injected. And after that, the neighbor is 10344. Neighbor 10344. And after that, remote AS is 65001. Address family IP4 unicast should be enabled. It's so easy. We have only one eBGP neighbor. Let me to copy the configuration in the switch 4, conf t, okay. And after that, we can check the result. I expect that quad 1/32 now should be available in the switch 4 BGP table. Why? Because switch 3, after establishing neighborship with switch 4, should advertise the loopback quad 1 to the NXOS 4. Also, here we have one error message. Look at here, neighbor 10344 cannot give locally, because the neighbor IPRS is configured neighbor 10344. The neighbor IPRS is 10343. Okay, and we should copy this configuration again, and after that we can paste it. Okay, very good. Now let me check the running config. In the running config, as you can see, we have router BGP 65002, router ID quad 4, address family IPv4 unicast, network quad 4/32. The neighbor is 10343, remote AS is 65001, and also address family IPv4 unicast now is enabled for this neighbor. Let me check the neighborship, show BGP IPv4 unicast summary. Yes, we have neighborship with router 3, and also we receive one pass from the router 3. What is the pass? Show BGP IPv4 unicast. The pass is quad 1/32. Don't forget that this passing is learned from an eBGP neighbor, but as you can see here, we injected ourselves the quad 4/32. Because of that, quad 4/32 now is advertised to the switch 3, and we can check the BGP table of switch 3. Let me check it. Show BGP IPv4 unicast. As you can see, we have quad 4/32 and also quad 1/32. Quad 4/32 received from the with the next hop of 10344 the IP address of the switch 4. Very good. Now let me check the switch 5's BGP table. Show BGP IPv4 unicast. Again, we receive quad 4/32 with the next hop of quad 3 because the next hop is changed itself, is selfed in the switch 3, and after that this next hop should be advertised to the NXOS2. Show BGP IPv4 unicast. As you can see, we receive quad 4/32 in the switch 2, and finally switch 2 should advertise this path to the switch 1. Show BGP IPv4 unicast. You can see that quad 4/32 now is received in the switch 1, and this is the function of route reflector. Very good. Let me check the connectivity between these two loopback IP address from the switch 1, ping quad 4 with the source of quad 1. Quad 4 is the loopback of the router 4, switch 4, and also quad 1 is the loopback of the NXOS 1. Yes, we have connectivity, and also if you want, you can use the trace command, trace route quad 4 with the source of the quad 1. Okay, as you can see, the traffic went to the 10122, the router 2, the switch 2, and then to switch 3, and finally reached to the destination. And it is the configuration of the route reflector in the NXOS. Don't forget, in iOS, okay, we are using the router BGP AS number, and then we can use the neighbor IP, then for example, route reflector client. This is the configuration we are using in the iOS. But in the NXOS, because it's neighbor structure NXOS, okay, we should configure the route reflector client under the for example, address family of a neighbor IP, okay, then address family AFI, and then sub AFI, okay, subsequent AFI, and after that we can enable route reflector client under the address family IPv4 unicast or some other address families. Very good. This is so similar to the configuration in the iOS. The concept is same, and the configuration has a little difference.